Hi, this is Chris Schomburg, and today what we're going to talk about is actually a solenoid. It's similar to a linear actuator, and that's actually how linear actuators work. It's a lot like a motor, but in this case we're going to operate it to only move in a linear fashion and not a rotational fashion. So in all, we're going to actually engage or energize this solenoid. And so this solenoid should have really a linear armature, and it should move in one direction. So it's really going to close, and that's actually what we're going to do. It's similar to kind of like a jackhammer or something like that, but that moves in two directions. It moves out and in. Here we're just going to move inward direction. And so to do this, what we're going to do is we're going to actually move that linear actuator, or that armature. Okay, this is a new word, keyword is the armature. We can call this a plunger too. We're going to move that in by applying a coil, or applying voltage or current to the coil. Now we actually have a pictorial diagram that I want you to go ahead and look at. You can see that we have three colors again today. We actually have the red going into the push button. Again, we're going to have a yellow in this case, and this is because we're going to have a yellow line because it's coming from the push button. It's going to be a high signal, and then we're going to go to ground off of the armature. Okay, so basically we went into the power of the solenoid and then to the ground, and we have a push button in series. That's basically the plan. The symbolic schematic right here that we're going to have is going to have a 12 volts applied to it, a push button, and then we have this armature. It looks like a winding, like a squiggly line, and then it has two lines on top of it. Really what that stands for is the winding is the inductor, and we're going to learn about this new device called an inductor pretty soon here. They're in motors, they're in all kinds of our devices, solenoids. That's actually what we call it. If it's by itself, it's a solenoid. The two lines on top of it, that represents an iron core. So what that means is that we have a metal that is called ferrous. It's a ferrous metal. It actually increases the magnetic field lines and increases the strength of the solenoid, so it makes it more powerful. That's actually how the diagram is given, and then that goes back to the 12 volts for ground. Again, I did use the right hand rule here, and I have it that the linear actuator is going the outward direction. It's not, it's actually going in one direction, which is the inward direction. So we actually should turn those magnetic field lines, and you use the right hand rule if you're going to do that. Assumingly, the right hand rule is if you have a coil or current going in this direction, you're going to use your right hand and you're going to curl it, and that's the direction of the magnetic field lines. And so if we curl it like that, we see the direction of the magnetic field lines. And so then if these are going outward, and I'm assuming they are because I'm assuming they're dots, they're going outward from the page, they're going to be curling in this direction if the current is that way. And I wrote it this way because it should be a negative electron flow. Now, the book actually did it the other way around. It did the positive electron flow. So, you know, it gets confusing because it's taught two different ways. Physics way is to teach positive current flow, and the electronics way is looking at a negative electron flow. So I'm going to teach you the electron flow in this case because I think that's more what's done in practice. Physics, obviously, they kind of do their own thing. You can do it either way as long as you use the same principles. Again, it's a right hand rule. So you're going to curl with the current, and that is going to show you the magnetic field lines. Again, if it's out of the page, you're going to see a circle. If it's into the page, you're going to see like what I consider an arrow. So the arrows feathers are going to be an X, and so you'll see an X, so you'll see the arrow going in the other direction. So if it's coming out, it's a circle. If it's coming into the page, it's going to be an X. And so that's the differences between how they designate this. So it's basically we're looking at a three-dimensional thing here now. And so that's kind of a cool thing. All right, so we'll go ahead and we'll build this. So we're going to assemble it now and see if it works. The first thing we want to actually make sure we do is just assemble it. So we're going to go ahead, we're going to choose our red wire. We're going to also choose our black wire and our yellow wire. There we go. And we have like a German flag. Woohoo! Okay, so now what we're going to do is we're going to hook it up from negative electron current flow. So negative, so we're going to go to the ground right there. Okay, then we're going to go from the ground to the solenoid. Okay, so that should look good. Then we're going to go from the solenoid, okay, and then we're going to go from the solenoid to the push button. And then from the push button, in this case, to the 12 volts. Okay, so again, that looks like current loop. Let's actually move these in real quick here. And if we look at this, it's looking like a loop right there. We can see that this is going like a loop like that, and then this guy is looping like that. So it looks like a full loop. And so we have our current loop right there. So now we're going to go ahead, we're going to turn on the power from the batteries. Okay, there we go. We're going to turn on the main power. We're going to turn on the DC power, and we are going to press it. And you can see that the linear actuator, or solenoid, actually pulled in that armature, and the armature just came in like a plunger and just came directly in. That's exactly what we should see. That's the result we're looking for, and that is great. So we're going to go ahead, we're going to turn the DC power off, the main power off, and then the solar power off. All right, so what we learned about today is we actually learned about a new type of diagram and device, and this is called a solenoid. Now, the solenoid is also called an inductor later, but really what we're doing is we're actually producing a current in that loop-de-loop kind of diagram. And so basically what's happening is, because we have loops of wire, we're actually causing a current to flow, and as that current flows, it creates a magnetic field line. And these magnetic fields then, in this way, because they're aligned in a way, they're going to actually cause a north and south pole. We're going to then cause, because we have that north and south pole, we're going to actually be able to move this metal rod in and out. And so that basically, because it's a ferrous material, because it's a solenoid, because it's an inductor, because we have a current flowing in creating a magnetic field, we can actually pull metal in and out. And so that's, we're pulling in that linear actuator. Instead of having it out, it's pulling in because of this magnetic field and the solenoid that is pulling it in. Again, if you use iron in metal in this kind of thing, you're going to have a much stronger and much more powerful field. They use this in the early radios. Early radios had iron, and they actually tuned. They use a tuner, and that tuner actually had the iron in that, and then it had the magnetic solenoid or inductor, and it allowed you to tune and change through stations. So it's kind of amazing how a very simple concept and thing can actually be used all across. We talked about radios. We talked about this is a linear actuator or a solenoid. We can actually talk about, a jackhammer in similar ways. We can actually talk about, in this case, a motor is where we're leading to, and how motors can actually operate and work. All right, well, thank you very much. I hope you discover more in science and electronics.